Hi everyone, this video reviews simplifying radicals, which is on page 18 in your Unit 4 packet. You should have actually learned this in Algebra 1, but there are two methods. Basically, we're going to simplify square root of 72, and we're going to turn it into a different version of a radical, but that's the same. It's kind of like, it's not the same as this, but it's kind of like, you know how 4 over 8 is the same thing as 1/2. Like these are two fractions that represent the same amount, 0.5. So the decimals are the same. What we're gonna do is we're gonna rewrite square root of 72 in an equivalent format that the decimals will be the same. Square root of 72 is not a perfect square. 72 is not a perfect square, so it's like 8.48. So we're gonna find another way to write a radical that also gives us this decimal answer. So option 1 is to use the largest perfect square. So first of all, you need to know what the perfect squares are. So if you want to make a list somewhere, maybe at the top of your paper. So the perfect squares, any number times itself will give you a perfect square. So like 1 times 1 is 1, so 1 is a perfect square. Two times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, 9 is a perfect square. 4 times 4 is 16, 16 is a perfect square. 5 times 5 is 25, and so on and so forth. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So these are the first 10 perfect squares. So the first option is to find the largest perfect square that goes into your number. So there's two ways you can do this. You can kind of do it in your head, or you can use your calculator. I'll show you both ways. So what I do is I take 72, I pretend there's no square root around it, and I find where it belongs on this list. So 72 is in between 64 and 81. And then I just work my way down the perfect squares because I want to find the largest perfect square that goes into it. Kind of like when you simplify fractions, like 4 over 8. I know 4 over 8 is 1/2 because you can divide the top and bottom by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. But if somebody else did this and they did 4 and 8 and they divided them both by 2, 4 divided by 2 is 2, 8 divided by 2 is 4. 2/4 is still an equivalent fraction, it's just not the simplest form. So if you use the largest number when you're simplifying fractions, if you use the largest number that you can divide them both by, you get the simplest form more quickly. That works the same way here. So there might be many perfect squares that you can divide 72 by, like you can divide 72 by 1. But you want to find the largest perfect square that you can divide 72 by. So if I situate 72 in between 64 and 81, can I do 72 divided by 64 and get a whole number? No. Can I do 72 divided by 49 and get a whole number? No. Can I do 72 divided by 36 and get a whole number? Yes, I can. 36 times 2 gives us 72. So that's what I'm going to write next. Square root of 36 times square root of 2. Now, if you were like, I'm not going to know what number goes into 72, you can go to your calculator, go to y equals, type in your number, 72, divided by x. When you do that, go to the table, and then you can look through the options. So you might say, oh, 1 is a perfect square, but is that the biggest perfect square? 4 is a perfect square, but is that the biggest perfect square? So you got to look at the x and y values to see if you find the largest perfect square. So as long as you have a list in front of you or in your brain about what the perfect squares are, you want to pull the largest one. So there it is, 36 and 2. So you can look at the table and decide. Once you get your two numbers, now you're just simplifying. The square root of 36 is 6, because 36 is a perfect square. Square root of 2, 2 is not a perfect square, it's not on our list, so we're just going to bring it down. I don't have to write the times symbol next to it anymore. It's kind of like if you did like 6 times x, like that. you could just write it as 6x. Same thing here. 6 times radical 2 is just 6 radical 2. So this is one way to do that. You can check to see if you're right, because if you do square root of 72 on your calculator, which gives us that 8.48 number, and if you do 6 radical 2 on your calculator, gives you the same decimal. So they do represent the same quantity. So I'm going to do this method a couple times, and then we can switch to a different method and see if you like that better. All right, so down here at the bottom, say we do number 1, square root of 75. So I go to my calculator. I'm going to pretend like most of you guys will like your calculator rather than doing it in your head. We go to y equals, type in 75 divided by x. Second graph is going to let you go to the table. So now you're just looking, whoops. Now you're just looking for a perfect square on this list. So you want to find the largest perfect square. So like you're looking, you got 75 and 1. This is a decimal, so we won't use that. 25 and 3. 25 is looking like a big number. It's the largest, it's the next largest number on this table. So 25 and 3. 25 is a perfect square. 25 is on our list. So you're looking for a number off the list. So square root of 75 is the same thing as square root of 25 times square root of 3. Square root of 25 is 5. Square root of 3, 3 is not a perfect square, so we'll just bring that down. Call it 5 radical 3. Again, check. Square root of 75, 8.66. 5 radical 3, 8.66. All right, let's try another one. Let's go to 80. So y equals 80 divided by x. So you're going to scroll through and see if you can find a perfect square on this. I've got 1 is a perfect square, 4 is a perfect square, but are these the biggest numbers? So let's look at some of these big numbers over here. 80 isn't a perfect square, 40 is not a perfect square, 20 is not a perfect square, 16 is a perfect square. So 16 and 5, this is the combo we're going to use. That's the largest perfect square. So square root of 16 times square root of 5. Square root of 16, what number times itself gives you 16? That's 4. Bring down square root of 5. I always write the perfect square first. The only reason why I do that on all of these examples, I've been writing the perfect square first, is because the standard form of this has the number that doesn't have a radical in the front. So if you didn't write it first, if you happen to write square root of 5 times square root of 16, and you were like, okay, the square root of 16 is 4, and I'm going to bring down the square root of 5. This is not like the normal version of how you would see things. You would then want to switch it around and call it 4 radical 5. Okay? So it doesn't really matter which order, just make sure like in the end you have it in like a standard looking format. Okay, so this is the largest perfect square method. So if you follow that, cool. If you prefer this method, it's called the prime factorization. So what you're gonna do is you're gonna make a factor tree. So say you have 72, and right now you're just gonna ignore the square root symbol. You wanna pick any two numbers that multiply to 72. You don't have to think of perfect squares at all right now. So maybe you think of 8 and 9. That's not the largest perfect square because we know 36 was. You're gonna keep factoring things. What is 8? 8 is 4 times 2. 4 is 2 times 2. I can't go any farther than this because now I've hit prime numbers. Hello? Oh, I do. Yep. Yes, you can. Yep.
Just reading that. I was trying to plan out the next couple of weeks, but I wrote it all down. There'll be a snow day now.
Somewhere.
Printed the wood.
I know I have, oh, this. This is weird.
Oh, beautiful. Do you gonna need them?
No.
Oh, okay, perfect.
Definitely not.
Oh, okay. Thanks. It probably won't be next week. It might be end of next week.
We're already done with that stuff.
You are? All right, I'll bring it back whenever.
Yeah, whatever.
Right, thank you.
Okay, thanks. Thanks, I'm just making a video. You're fine. All right, so 2 times 2 is 4, so we're gonna have to stop there. There's no other factors that go into 2. So if I go over to 9, I got 3 and 3, and 3 and 3 are both prime, so I can't do anything here. So these are the numbers that we're gonna focus on to get this same answer of 6 radical 2. So what you're gonna do is you're gonna find a pair. So a pair of 2s. Pair of 2s. 2 times 2 is 4, so this comes from square root of 4. Let's find another pair. So we've got a pair of 3s. Now the pairs don't have to be sitting right next to each other. These ones happen to be, but they don't, as long as you can find a pair. So 3 times 3 is 9, so I've got square root of 9. This last one, this random 2 that doesn't have a pair, we're also going to bring that along. So what this is saying is that 4 times 9 times 2 gives you 72, which is true. Now we're going to simplify. The ones that have pairs are perfect squares. So the square root of 4 is 2. The square root of 9 is 3. And then square root of 2 is not a perfect square, so we'll just bring that down. We can simplify the ones that don't have perfect squares. So 2 and 3, that makes 6. And now we have the same answer as before. Now, factor trees can be longer if the numbers are larger. And also a trick for factor trees is you can skip this step. If you know that these two match, you know you're going to create a 4, which is going to give you back a 2 when you take the square root. So if you want to jump right to a pair of 2s gives you a 2, a pair of 3s gives you a 3, you could do that. Something that doesn't have a pair stays under the radical. So say we try that with 32. So you pick any two numbers that multiply to give you 32. Maybe you do like 8 and 4. Not the biggest perfect square, but whatever. So then you're going to do 8 is 4 times 2, and then 4 is 2 times 2. This 4 is also 2 times 2, and now you're going to look for pairs. So these are prime. So you got a pair of 2's right here. 2 times 2 is 4, so square root of 4, which is 2. You can do it all at once if you want. We got another pair of 2's. It doesn't matter which pair you're looking at. They don't have to come from the same factor. So I got a pair of 2's right there, so that's another square root of 4. 2 times 2 is 4. Square root of 4 is 2. Then I have this random extra 2, so I'll bring down square root of 2. Now I can multiply these together since they both don't have square roots. 2 times 2 is 4, so 4 radical 2. Again, you can check the same way we checked before. Square root of 32 is 5.65 whatever, and then 4 radical 2 is the same. Let's look at 18. So 18, if you like this method, so maybe you think like 6 times 3 gives you 18. The beauty of this is that you don't have to even, you and somebody else can get the same prime factorization at the end without starting with the same numbers. 6 is 3 times 2. So I can't go any farther because there's no more factors. So those are my numbers. Now here's one where the pairs aren't situated next to each other. I'm still calling this a pair of 3's even though they're not sitting next to each other. So I've got a pair of 3's, which is square root of 9, which is 3. Then I have this extra random 2, so this is a square root of 2, which, bring that down. So again, if you notice that there's a pair of 3's, just means that a 3 will be out front. That might be a quicker way to do this, but square root of 18, 4.2, 3 square root 2, also 4.2. So those are your ways to simplify radicals. Whichever way you prefer is fine with me.